and thank you for attending today's webinar titled GIS Essentials for NextGen 911. This webinar is jointly presented by Esri and Intrado. My name is Brinton Bromley from Esri, and I will be joined by Raymond Horner in a few minutes. Before we get to the key message around GIS and NextGen 911, I want to cover a couple logistics for today's webinar. Next slide. The webinar is being recorded and all attendees are on mute. Please ask any questions during the webinars using the question panel on the right side. We will do our best to answer questions during the Q&A session at the end of the webinar. In the event that we can't get to your questions, we will follow up you individually on your questions with answers. But please submit any questions you have. We'd love to have more questions than no questions. And then one last item, this recording will be made available a few days after the end of the webinar. Next slide. So Esri has an emergency call taking and dispatch team, and I want to let you know that they're on the call today, and I just want to introduce them to you. Mike King is our industry manager for the space, and then Wayne Sweeney is our sales lead for the NextGen 911 space. The three of us together, our mission and goal is really to support our customers and partners to have successful implementations of NextGen 911 on the Esri platform. Next slide. So, kind of reiterate the goal and the purpose of this webinar. It's to understand the role of GIS and that it's data critical to the success of your NextGen 911 implementation. And today we'll be covering on NextGen 911 GIS terminology, the elements of a NextGen 911 system, the transition to geospatial call routing, GIS data requirements, and other topics. So what are the GIS tools for NextGen 911? Well, it would be the ArcGIS platform. So we think about GIS being used for mapping, data management, and that could be creation or editing of data, location validation, routing, and many other topics. But the reach and the importance of GIS is much broader than the traditional desktop server environment, which a lot of people are familiar with. Organizations are discovering the value of sharing and collaboration through the web, through mobile devices, and shared hosted services. On this diagram, you can see how the ArcGIS platform extends the reach of GIS beyond the traditional GIS professional, which is in the lower left, to the cloud and on any device, anytime, anywhere. Next slide. Another way to look on how to extend the reach of GIS is to consider the activities, or you could say the patterns within your organization. So when you look at this 6 patterns, how many of the patterns are you deploying? Some keys to achieve successful patterns deployment is to have GIS capability embedded into your operations, have defined workflows, have a content data management strategy, and have mission-specific application. Some of these things that Raymond will be covering in the body of this webinar. When you expand the role of GIS, looking at these activities and patterns, you can promote smarter NextGen 911 through collaborations and communication with other agencies and states. And this is going to be really important. We see that the sharing across boundary lines are growing and more important. It's not just about your agency and your data set, but it's about interoperability with other data sets in other agencies and other geographies. Next slide. Esri has a great ecosystem partners who are committed to your success. NextGen 911 is a well-known term, but it's equally confusing for many of our GIS professionals or industry workers. The goal of this webinar is to help our users to understand the role of GIS in the success implementation of NextGen 911. At this time, I'd like to introduce Raymond Horner of Intrado, who will be presenting the essentials of GIS and NextGen 911 and how Intrado leverages ArcGIS in their solutions and services. Raymond has over 10 years experience in the GIS services industry. He has worked with oil and gas companies and state, county, and local government agencies on various GIS projects. Raymond has worked in the public safety GIS industry as a technical product manager for 5 years and also is the product owner for the Intrado 911 Enterprise Geospatial Data Management System, which serves as the GIS data processing and provisioning engine for Intrado's NextGen 911 systems. With that said, I'd like to hand this off to Raymond.
Thanks, Britt. Much appreciated. Welcome everybody to the webinar. Just wanted to start off with a little bit of my background about some projects that I've worked on in the past. And the common theme with all of these projects is that they are all about GIS data management and specifically preparing GIS data for NG911 deployments. And so that's the common thread here. A project that we worked on here at Intrado was the New York Street Address Mapping Project, or SAM project, where we created address points throughout the state for basically the entire state, excluding the New York City area, creating NG911 compliant and highly accurate GIS address point database. It was a great project working with New York State on that. And again, that was kind of for the goals of NG911 implementation in the future. Also currently serving as the State of New Mexico project manager. In New Mexico, we're compiling data from all the local GIS data sources and compiling those into a single seamless statewide GIS database and provisioning that currently to their PSAP mapping applications. They're currently in an E911 system, so there's no NG911 going on there yet, but we're working with them and moving towards those goals. Also with the state of Delaware, working on an NG911 implementation there, where I serve as the GIS project manager, but that's an end-to-end NG911 deployment that we're working on with the state of Delaware. So cool and fun and exciting things happening out there. And as Britt mentioned, I am the 911 EGDMS, or Enterprise Geospatial Data Management System product owner. So I'm working on a system that will do the processing and provisioning of GIS data from the local data sources into regional and state level systems, and then provisioning those to our NG911 call routing systems like the ECRF and LVF, which we'll cover later in the webinar. Also an active member in the NINA NG911 GIS data model work group and ECRF LVF provisioning work groups, so trying to work on the standards for these systems. So that said, I wanted to provide some background on NG911, and I won't stay here too long. I want to kind of dive into the details of some of the GIS data management aspects of NG911. It is a large topic, and there's lots of things to consider as far as, you know, PSAPs, CPE, networks, ESI nets. Just there's the whole gamut of things that you can discuss for NG911. But the topic of this webinar, as Britt explained, is more about the GIS data practices and things that need to change to support NG911, as well as some of the detailed data elements that will need to be changed in the GIS systems. Understanding that our audience here could be some PSAP side or some 911 side, and then also some GIS professionals that are using GIS in their daily activity. I'll try to provide an overview and also some details, so there's a good blend there. So NG911, what is it? It's basically, the big shift is the transition from wireline or basic telephone 911 service to a IP-based 911 service. So you have the concept of an emergency services IP network, or ESI net for short. And within that network, you can have multiple layers of connectivity to different data sets, enhanced data, imagery, also more connectivity with adjacent PSAPs and even PSAPs across states and across jurisdictional boundaries, more so than we have today with the legacy 911 or E911 systems. So with that network of networks comes increased capabilities, technology advancements, and everything that we can, more things that we can do at the call center, empowering call takers to help dispatch and help first responders get out to callers in need. With that comes some prerequisites that we need to have or take into consideration for NG911 deployment. And one of those, and as we're talking about today, is how GIS and the role of GIS systems play an important role in NG911, and specifically the call routing elements. But with implementation for NG911, there's different things that need to be, let's say, procured, purchased, or otherwise paid for. And some of those things are tangible. You know, you need to buy a network, or you need to get X number of positions at a PSAP for a CPE. I think what's sort of a hidden cost of NG911 is the GIS data management or GIS data preparation costs that need to be the steps that need to be taken before you implement an NG911 system with the GIS and its role, and I guess its new role within the system. So those costs can vary, and it's important to consider where your jurisdiction is from a level of completeness and a level of accuracy within the GIS system, what it's being used for today, and how it's going to be leveraged in the future with NG911. So we'll cover some of those considerations here today in the webinar. With that, just a quick background of basic E911 call routing. And when I have a live audience, I usually like to ask in this slide where GIS data is used within the call flow. And basically the answer is it's really not used until the call taker has already picked up the call, picked up the phone, answered it, and then at that point in time is when the ALI information or the automatic location information comes from the ALI database and is then geocoded or georeferenced against the GIS database to display the caller's location to the call taker. So GIS is used obviously within 911 as it is today, but it's used as a reactionary tool to identify callers' locations after the call has already been placed to the PSAP. So GIS is not used in the call routing itself with E911. The call is placed, and then basically using an ESN and MSAG selective router database, the call is basically passed to the PSAP based on the ESN number that's in a fixed tabular database. So there's really no GIS involved there. So the ALI example that I have here is just a basic one, and at 1234 Main Street, and we see that it's in New City, Colorado, and then ESN 456. So this is just a tabular display or a tabular view of that ALI record. And I'm going to use that exact same ALI record to sort of go through a NextGen 911 call routing process. So we'll use the same address and just kind of see how that works with a geospatial call routing. Okay, so just background on GIS for those GIS professionals on the phone. This is pretty basic, but for others, we just want to cover that the basic three elements within a GIS system are points, lines, and polygons. Lines traditionally within 911 system, or within a 911 data set, would be your road center lines. That's the most important line segment in your GIS as far as call routing goes. So your road center lines. And then points, generally that's going to be your structures, but it could be points of interest, could be common places. It's just general your points that are carrying the structures, the houses, and other businesses in the area. And then polygons are going to represent your 911 response boundaries, including your EMS, fire, law, and then for call routing purposes, your PSAP boundaries. So those are your three main elements within GIS. And this slide really kind of represents how you can, or does the comparison of how tabular data can be displayed or visualized in a GIS-based, in a GIS system. So on the left, we have basically a street range of, let's call it 100 to 399, and that's on 10th Street. And basically the ESN that's represented by that MSAG range is B3. On the right side of the screen, you kind of see that the street segment broken up from 100 to 399 on the range, and then the polygon that represents that ESN boundary in B3 kind of shows you the spatial representation of what that MSAG record would look like in a GIS system. Then on the other segment to the right, you have 400 to 499. So that segment is in ESN A2, and you can see how that's represented differently in the MSAG and then how that's shown in the GIS system. So that's kind of a basic diagram that shows the difference between MSAG or tabular data management and GIS data management as it shows or correlates from road center lines to polygons. Okay, so there is a lot of terminology within NG911, and rather than put all of that out here and overwhelm everybody, I just wanted to try to limit those key critical elements that really use GIS and then just really focus on these so that we can kind of do a deeper dive into these elements and not worry about all the other things that are necessary, that are critical for NG911, but not necessarily a GIS component. And again, I'm also focused more within this webinar on GIS data management from the 911 authorities perspective, and not necessarily the call, let's say the network side or the call routing path itself. I'll touch on that, but I really want to focus more on how GIS is used in call routing, but how it's managed as well at the local level. So with that, we basically have these four that I wanted to focus on, which is the spatial interface. And for those of you that have been in the industry for a while, that was formerly the SIF, or Spatial Information Function. And that's recently, I guess, as of the last year or so, changed to spatial interface. And the main responsibility of the spatial interface, or SI, is to provision GIS data from a local data source up to the ECRF and LVF NG911 components. So what are those? Those are the location validation function, which is basically used to validate civic addresses against the GIS data. So that can kind of be correlated to an E911 correlated to the MSAG. It's basically holding all of the data, and then as records need to be validated, instead of getting validated against an MSAG, they're getting validated against the location validation function. So we're doing address validation on the GIS data as opposed to a tabular data set. Then the emergency call routing function, or ECRF, is what actually provides the routing instruction based on the civic address at the time that a 911 call is placed. It can also be based on the geodetic, so an XY coordinates. If you have a lat long that's coming with the call, then you can also do routing based on the lat long within the ECRF. But the important thing to note here is that GIS data flowing from the local data source up to the ECRF LVF, it needs to be the exact same data that's in both the LVF and the ECRF, so that we're routing on the exact same data that we're validating against. And it's important to note too that the location validation aspect of this happens before there's an E911 call placed from that address, because the location is validated when it's inputted into the system rather than at call time. Whereas the ECRF component comes in at call time. When the 911 call is placed, then we look to the ECRF for call routing instructions. And I have a diagram that covers that here in a minute. The last aspect that I wanted to cover in detail is the known as the PIDA flow, which is the presence information data format for location object. And basically that's a standard that has been put forth within the new documentation for storing the civic address information and basically encapsulating that and carrying that information along with the call. And that's an important aspect that's changing. Currently with E911 systems, the call is placed basically with just the TN number coming across. So when the call taker first picks up the phone, really for the first few seconds, they only see a TN number or an ANI. And then the location information or the alley information comes in after a few seconds as far as that TN has to dip over to the alley database and then presents the location information to the caller. But with NG911, because we're able to encapsulate information or location information and embed it into the call with the network-based infrastructure, then the caller's location can actually be embedded within the call when it's placed. And that is encapsulated in that PIDA flow format. A goal of mine also today is to kind of go into the details of, or I would say kind of demystify what the PIDA flow is, to put it more in layman's terms that most GIS folks are used to seeing. So we'll do that here in a slide or two. But quickly, just a quick diagram. I won't run through this in too much detail, other than I wanted to point out that the local GIS data, which are the circles represented at the bottom of the screen, represent 911 authorities, individual ones that are maintaining data still at the local level, but are passing that data through the SIF or SI, spatial information, or spatial interface, I should say, and provisioning that data to the LVF and the ECRF. So even though those are in two different locations, like I mentioned before, that needs to be the same data feed going to both LVF and ECRF, so that we're validating against the same data in both the LVF and then also with live call routing. So just a quick overview of this is, and I don't have this listed, but the list in my previous slide, but the list is a location information server, and it's technically a sort of the counterpart to an ALI database, in that it's storing the records, storing the locations associated with devices, and those records is what needs to be validated against the LVF. So you can see that line between the list and the LVF. That's basically a validation process that occurs between the records in the list and the LVF, making sure that those records in the list are valid. And then at the point of a call coming through, basically that information from the list can be carried with the call in the PIDFlow format. It's carried into the ESRP, which again, I didn't cover that in detail because it's not necessarily the GIS component, it's just the emergency service routing proxy. It's basically the routing engine. But the ESRP sends the location information to the ECRF, for the emergency call routing function, and it does a point and polygon lookup based on the location of the device, and it looks for the polygon that corresponds to that location. So generally speaking, that's going to be the PSAP. Once it returns the PSAP to the ESRP then has the routing instructions to forward that call to the correct PSAP based on location. So there's other elements here, but again, don't want to cover everything. I just want to focus on the GIS. It's important, just again, the focus of this is the GIS, the spatial interface, and then provisioning out to the LVF and ECRF. That's the main sort of aspects that we're concerned with for today, and then especially the GIS location, or I should say the GIS data management at the local level, and how that needs to be brought up to more of a regional and state level, which Britt mentioned at the beginning, that no longer do we have isolated islands of GIS data where everything stops at the county boundary and there's nothing beyond that. Everything needs to come together into more of a regional or more of a statewide, or even more regional, bigger than states, I should say, especially in the smaller state areas, that you'll have multiple states coming together for a regional 911 system. Okay, so with that, wanting to get a little bit into the details here, some of the GIS data that's required and how it's managed. So, and also just generally the call routing path for NG911. So the PIDFlow, as I mentioned earlier, the presence information data format location object. There's that, and there's also some different data standards that are out there within 911, or I should say within NINA documentation for I3. But not to confuse everyone and have to go look up different versions of documents, or I should say different documents that are covering different things. The most important thing to note here is that the NG911 GIS data model has basically looked at all the requirements, whether it's the PIDFlow or the CLDXF, which is the Civic Location Data Exchange format, and all these other standards that are out there, FGDC standards, US Pub 28 standards for standardization of address elements, and basically taken all of those things into account and put that into an NG911 GIS data model that's currently being worked on and is under review. Hopefully, we'll get finalized and turn into a standard next year sometime, hopefully early. So that is an important thing to note, and an important document to keep an eye out for from the GIS data management perspective. But with that, know that the NG911 data model will cover all the aspects of the PIDFlow, but I did want to talk about the PIDFlow to just kind of sort of represent how that works within an NG911 call routing system. So you can see here the different elements. It's kind of a hierarchy data management, or a hierarchy data element between starting at the top level, which is the country. And hopefully everybody can see this. I know the text is kind of small, but you've got country. Then you've got A1, which is a national subdivision like a state. Then A2, county. A3, city, and so on and so forth. I'll go through some of those at least down to the house number level. But on the right side, you'll see also some more detailed location elements like the floor. There's also going to be like the room, and definitely more details that we can get down to with NG911. And that's more important when we start talking about location technologies that are coming in the future with indoor location accuracy increasing using Wi-Fi hotspots, et cetera. It's going to be important to carry the same level of detail that's possible with device locations like cell phones and Wi-Fi hotspots and things like that, to match that same level of detail within your GIS system. And that's kind of down the line, but that's the sort of thing that's coming with that level of accuracy and capabilities with that. But as far as point and polygon call routing goes, I wanted to talk about just the general, what probably most people know of as a geocoding type of system. But generally speaking, geocoding has a area that's a defined area in the GIS with a defined list of locations or addresses that need to be geocoded against that known GIS data, our data set. But with NG911, because we can have network of networks and we can have calls originating from different locations throughout the country, it's important that we use that hierarchy or PIDFlow to know at the very highest level where that caller is coming from. It's especially important along borders. Like if you have Canada, nearby, or if you have Mexico nearby or something like that, you have to be sure that we know, first of all, that the call is originating in the USA, for example. So that top level element of the PIDFlow is country. So we basically can look at that and say the country is USA. And from there we can drill down, and it's sort of that hierarchy element. So within USA, the state is Colorado. So our A1 element is equal to Colorado. And zooming down another level, our A2 or county is new county. I made that county up for purposes of this webinar. There's not a new county in Colorado, but down another level, you can see city. So our A3 element is equal to new city. There's also subdivision and neighborhood elements within the PIDFlow, but those are not required as not everyone maintains those within a GIS, so we can skip over those for null attributes in those. But then once we get down into the street elements, then this is where we'll probably start looking very familiar to most GIS professionals that are maintaining data, in that you have your street elements broken out or parsed into your street name, your pre-direction, post-direction, street suffix, etc. So basically, what I detail here was that Main Street or within Main Street, you have an address range associated with Main Street. And if you were looking at the road center line, you would have, in this case, 1200 to 1299. And if we had a house number or a record that came through and was hitting the PIDFlow, or using in the PIDFlow, hitting the ECRF with this location of 1234 Main Street, we could either look to the road center lines and use a geocoding along that road center line range to estimate that 1234 is on the right side of the road, close to halfway up the road segment. So road center lines are a mandatory element of an ECRF, but alternatively, if we had address points in the data set, hopefully the address points would be placed on the correct structure and therefore more accurate, then we could look to the exact address point and find an exact match to the address point. So you can either do road center line geocoding or address interpolation against the road center line, or you could do an exact match to the address point. Once we've found that caller's location based on the PIDFlow and based on that civic address, we're basically overlaying our response boundaries on top of that. Within the ECRF, you would have your fire law, EMS, and PSAP boundaries. So shown in orange, we would be able to identify that this is the new city PSAP, and then new city FD, PD, and EMS for fire law and EMS. So at that point in time, then the ECRF would return the PSAP, identify the PSAP as new city, send those instructions by URI, which I'll cover here in a minute, but send that routing instruction over to the ESRP. The ESRP routes the call to the PSAP based on that polygon. So just shown another way, this is a graphic just displaying the different elements, the different polygon layers that can come together and how those can be different polygons for different areas, I should say for different responders, fire law, EMS, and PSAP. But generally speaking, the 1234 Main Street, you find that location, and from that single location, you can do point and polygon lookups to find both the PSAP to route the call to, and also the first responders for that area, fire law and EMS. And it's not just limited to those four. There's also going to be, Coast Guard, different elements that can be represented there as far as the type of response that we need. Okay, so going into a little more detail on the GIS data layers that are required for NG911. The required data sets, as I mentioned before, you do need to have street center lines because that's basically used as your primary, or as I should say, as the baseline that's mandatory for locating callers with civic addresses. Strongly recommended, though, are site structure address points. Again, more accurate to use an actual point that's been placed on the structure as opposed to the street centerline geocode. But required is street centerlines, then also your PSAP boundary, your fire law and EMS boundaries, and this last one here, authoritative boundary. That might be new to some of you depending on how involved you've been with industry standards that are evolving, but the authoritative boundary is basically a boundary that represents the geographic area that the agency is responsible for maintaining GIS data for 911 purposes. But there has been a lot of recent discussion within NENA work groups on the authoritative boundary. And so it's kind of an evolving standard, but there might be authoritative boundaries for each layer so that one agency might be responsible for the polygons, but another agency is responsible for the street center lines and address points, et cetera. So there's more standards to come on that, but all of that should be in the NG911 data model. Strongly recommended, as I covered already, the address points. Also, you can have a road name alias table for different local names and other names for your street segments and your address points. Also, cell site and sectors, just to have that as that's not used currently for call routing necessarily, but it's good use for visual display to the call takers for where those cell sites are in those sectors. Then also, of course, your general civic boundaries, municipal, county, state boundaries. In addition to the layers, there's going to be additional required attributes. And within those, I mean, there's a lot to cover there, so I don't really want to go into too much detail. All of these standards will be included in the NG911 GIS data model. And I guess the one that I did mention earlier is the URI and URN. Those are basically routing column URL endpoints for PSAPs and responders, and those are some elements that probably most people haven't heard of unless they've been involved with NENA standards development. But those will need to be added to GIS data and assigned from your network providers to basically have an endpoint within a network or a network address for your PSAP and your fire law and EMS boundaries. So that's just an example of some new fields that probably aren't maintained currently in your GIS data, and so it's important to look at those standards to see how that's changing. Okay. So general transition to an NG911 data management system, and basically looking at this from a hierarchy of what's most important and what's critical or where you should start, is we generally recommend starting with your service boundaries. Like I mentioned, the authoritative boundary, as you can imagine, would be pretty critical to work with your neighbor agencies to be sure that you're not sending the exact same data overlapping one another, or otherwise, maybe claiming that you are responsible for the same area. It might be a county and a city that are both claiming jurisdiction over the same block. They need to get together and work that out to see who the actual authority is for that area. So it's important to start with those authoritative boundaries, and then also your PSAP, fire law, and EMS to be sure that you have clean boundaries, not only clean from the GIS management perspective, like gaps and slivers, but also just from the jurisdictional boundary perspective. And then once you've got your service boundaries cleaned up and in sync with your neighbors and in good shape, then that's where you can usually get moving on your street center lines, because those need to be snapped to those service boundaries and edge matched against neighbor boundaries and things like that. So it's best to start with service boundaries, then move to your streets. And then generally speaking, address points are validated against street center lines. So that's why the address points would come after the street center line, so that you can run validations against your streets, and then also increase the accuracy of your address points. And then once you've got that, then that sort of allows, once you have an NG911 system in place, it allows you to have additional information. Floor plans, could be oblique imagery, cameras, you can bring all these different feeds in, additional data outside of just GIS data. So with that, there's some considerations that there's a lot to consider, and what we've done is we've kind of taken some of these questions, and then we have sort of a 5-step approach to how you could look at all this and steps to take towards managing GIS data for NG911 purposes. But I'll run through some of these questions because they are important to consider. One of the first ones we look at is, and what most people have talked about for quite a while, is syncing up your GIS data with your existing 911 databases. So how well is your GIS data matching your MSAG? Do you have all your streets represented? Are your street naming conventions similar? Do you have your communities matching? Generally just getting that in sync so that also not only is required for NG911 to get that data in sync and have everything match, but it's also important for E911 so that when callers are currently calling 911, you have that data in your GIS. NINA recommends a 98% match rate. That's between your GIS data and your MSAG, but also importantly is looking at your actual TN records or your ALI records to see how those match up to your GIS data. You want to be sure that you don't have ALI records falling outside of your GIS ranges, either the address number not matching the GIS road centerline range, but also are your street elements, your street naming elements parsed correctly to match your data, and are communities matching, etc. A lot of times the MSAG community is different from the communities that are managing the GIS, so it's important to sync those up and work with the 911 addressing coordinator and the GIS data management person, and basically that's another change I think that we're seeing is a lot of times the 911 addressing coordinator traditionally has been not necessarily a GIS administrator, but you also had a GIS administrator. Those two folks need to talk, need to work together, and the other trend we're seeing is sometimes those are becoming one, to where the 911 addressing coordinator is also doing the GIS. So it's important to keep those in sync. Other considerations, do you have an ESN layer? Is that ESN, can that be broken into fire law and EMS? Do you have, just generally, do you have all the data layers that are required for NG911, which we covered earlier? And again, do you have software? Do you have the resources, the budget? All of these things need to be considered. And we'll go over here in a minute a few of our software packages, how we leverage Esri technology in our products, and kind of give you some information on those products. But then additionally, should you contract all or part of the work, this, like I mentioned on one of the first few slides, is this can be the hidden cost within an NG911 deployment. Do you need to hire staff? Is it a project that we could, that you could look at as a single project and maybe the data needs to be built out? And I'll also cover an example of a project we've worked on here recently here in a few slides. And then last but not least, just the overall GIS data workflow, how data flows between local data sources up to a regional level, up to a state level, data sharing considerations, etc. So with that, there's a lot to cover there, but you basically got five different processes that we suggest as far as getting your data ready to go for NG911. So it starts with assessing what you currently have, making a plan, doing collection for missing data, cleansing that data to get it QA/QC'd, all the attributes cleaned up, and then finally implementation. So within those different processes, we've kind of broken down just a general plan, if you will, for assessing your GIS data. And it's generally saying kind of an audit of what data do you have available. What layers do we currently have? Do we have ESN polygons, but we don't have fire law and EMS? Some areas don't necessarily have ESN polygons, so they might just have roads and address points. I know some agencies maintain address points, but they don't have every address point covered. So do we have some address points but not everyone, or do we have the address points in the rural areas but not in the city areas? Things like that need to be considered. Just because you have a layer doesn't mean that it's complete to the level needed or accurate to the level needed. So again, what fields need to be added to the data. You could have a database that you maybe got from a third party or maybe got from the tax assessor collector, but it doesn't have all the elements that are required for 911 purposes, and especially for NG911 purposes. So start evaluating that, and then validating data. This is a pretty important key element to data management. Is you can have the data in-house, but you have to validate that data, get it standardized, etc. And then, like I mentioned before, that MSAG compare, doing a sync up or doing a validation of your existing GIS data and comparing that to your existing 911 databases, your MSAG and your ALI, to see how those match up and to start filling in the gaps for the missing information. Excuse me. So once you've done your assessment, you have an idea of everything that you need to do. You want to try to start to make a plan. So what are our options? Are we going to do this with the existing staff? Are we going to work with other local agencies? Like, can we go look at the utilities, the local utility companies? Can we look at, the tax assessor or the appraisal district? Where can we get this missing information? Do we need to go do field work? Can we purchase it from a third party? Where can we obtain the missing information? And then personnel. What personnel and skills are required? You might need to hire a GIS person or an additional one. You have to just take those things into consideration. And then software. As Britt mentioned at the beginning, Esri offers a full suite of software products and services that are designed to help facilitate the GIS data management from end to end. So local data management at the desktop level, all the way up to a regional cloud-based web-enabled system to where the public can access those things. Do some sort of crowdsourcing for filling in missing information. All of that is possible with the Esri technology and the way that they've leveraged local data management, but then all the way through more of a web and more of a broad data sharing aspect. So documenting what processes and responsibilities there are, and then again funding. That's kind of been a big theme here. Is where is the funding coming from? We're hoping to see some NG 911 funding from the federal level. Hopefully, there's some things that have been discussed there to try to help folks out from a federal level as opposed to just the local level. Okay, collecting data. So now that you made a plan, we need to get out there and collect data. Is there going to be field work that has to be done? Do you have to try to go to the fire department, go to the police department, try to get these different boundaries drawn in and digitized if you don't have them yet? Or if you do have them, validating that those are accurate, and make sure that they're current and up to date and weren't from 5 years ago or something. Attributes, add and populate the missing fields. Basically, you're going to have to add fields. There's really no doubt about it that to move to an NG 911, you're going to have to add fields and potentially break data down even further than you currently have it. So you might have good, clean data right now, but you're going to need to parse something out, additionally, or you're going to need to take your house number, which currently is a string field, and you have A's and B's and slashes in there. You're going to have to turn that into an integer field and then parse out those other special characters into an address number suffix field, for example. So you're going to have to do some data cleanup to get things to standards, because currently in the standard, the house number is an integer, and then any half or A or B, et cetera, has to be split out into the address number suffix. So that's an example of just those attributes, how we need to fill in, get things ready for NG 911, and get things ready for that location validation. Same thing with streets, kind of that parsing and validation of that, and then points, and just getting all of that data collected and in-house. And then finally, cleansing. I kind of touched on this on the last slide, but yeah, that cleansing, doing the validation. Do you have gaps and slivers within your polygon boundaries? We have to get all those cleaned up so that with call routing, you don't have gaps in the responder boundaries, or you don't have overlapping boundaries to where the system has to determine arbitrarily which PSAP to route to. We want to have one and only one PSAP for the correct PSAP in the system. And then again, I've already touched on this, but your attributes, your streets, your points, just doing that cleanse, doing that validation, and using tools to help with that validation. And finally, once you've done all that work and you've collected all the missing information, you've validated, you've done the cleanse work, you've used the tools, the Esri tools, the Intrado tools, and different tools that are out there for 911 purposes. Once you've done that validation, you've got the data cleansed, you're ready to do an implementation. There's some considerations to look at for implementing. You might have to look at the CAD system that's already at the PSAP. Is everything going to be interoperable with the CAD system or with the 911 call-taking map display at the PSAP? So there's different things that you need to consider aside from just NG 911. Yes, we're getting the data ready. We're going to put it to the spatial interface, and it's going to go to the ECRF and LVF, but it's also needing to be pushed over to the CAD system or being pushed over to the PSAP map display. So you have to be sure that you take that into consideration as far as any schema changes that you've done to the data. or other information you've added to it to make sure that it's compatible with all your systems that are using that data. So once you've gotten your data, you're ready to implement, just make sure that you have a data maintenance plan in place. It's pretty critical. Obviously, we can't just deploy the data today, say we're good, and not do anything to keep that data moving forward. We need to keep a maintenance plan in place, and that involves all, everything that I talked about, the 911 addressing coordinator, to all your stakeholders, to all the folks at the PSAP, et cetera, keeping that data in sync and having that data maintenance plan in place. So quickly, I want to cover a few of our products and services and also past projects that we've completed here at Entrado. A really neat one that we did was in Atoka County. This is in Oklahoma, and we utilized Esri technology in this, and in fact, we used the Esri collector for our GIS system out in the field, which was really nice. We used Android tablets and ArcGIS Online to collect the data, and it was neat that our field workers were able to be out in the field collecting data using the tablet, using the ArcGIS for collector app, and then could sync up that data in sort of near real time to push that data back to the local, back to our main offices, where we are using SDE and basically ArcGIS for the in-house data management. And in addition to the field collection, we also did MSAG and ALI database synchronization, and also digitizing, creating those fire law and EMS boundaries. So this is an example of leveraging Esri technology, but also just doing that kind of end-to-end GIS data management work for a county, and in that considerations of, do we hire, do we do an outsourcing to a company? This is an example where we were, Entrado was hired to do that database build out, cleanup work, and basically the kind of the A to Z data management for that local agency. Another application that we offer at Entrado is MSAG. This is basically a GIS data management tool that's an extension with Esri ArcGIS for desktop. It's important to note that you can use all of the ArcGIS tools. It's basically you're using the entire ArcGIS desktop tool set. In addition to that, we have some custom specific 911 data management tools within MSAG that are useful for doing comparisons to your MSAG and also doing comparisons with your ALI database. So this is a tool that really enables that validation and that synchronization of the MSAG and the ALI that we talked a lot about today. Mentioned at the beginning that I'm the product owner for the EGDMS, or spatial interface component, and basically this is a system designed to take data from the local data sources. So that would be like the individual boxes on the left, your GIS data from the local 911 authority. Then they provision that data into our system. This is also using SDE technology on our back end for our enterprise GIS database. Doing that validation, reporting back any errors back to the local agencies, so that they can make edits to the data, get it up to par for NG911 use, and then once it is validated and deemed fit for use within the NG911 system and call routing and location validation, then we provision that data from EGDMS out to the ECRF and LVF. Lastly, we have the Entrado MapFlex 911. So this is our emergency management mapping application. This would be the PSAP, or the map that the PSAP is using, and the call takers are using this to locate callers. This is built again on Esri server technology, and a great thing about this is the ability to update maps at a central server basis rather than at the individual workstation, so that it makes updating maps and keeping your GIS data up to date to the PSAP that much easier. We also have a lot of integrations with third-party applications for bringing in additional data, like you can see here the oblique imagery that's being brought in with pictometry and other imagery services. So with that, I wanted to point you to some additional documentation or additional reading that you could do that covers a little bit more detail about the big picture of NG911, in addition to just the GIS aspects. So you'll notice the URL at the bottom of the screen. This is basically just right on our homepage. If you go to Intrado.com, you'll see on the right panel NextGen 911 guides, our essential guides, and basically we have 4 volumes that are out there now. One of them is on just getting started, basically an overview. Then we have a text to 911 guide, IP-enabled PSAP, and then GIS data management. And that's going to be the one, volume 4, that really covers in a little bit more detail what we covered here today. So I think that if you guys went and checked that out, you'd have a good wealth of knowledge out there in those guides. And with that, that concludes my presentation, but we're going to have a Q&A session, and I've asked Sean Whitehead to help facilitate that Q&A session. So we're hoping to answer a few of your questions here live, and the ones that we don't get to, like we mentioned, we'll follow up with you directly. So Sean, if you're there.
Yeah, all right. Great presentation, Raymond. We've got several really good questions, so I'm going to jump right into it. So the first question that I had here was, do you know of any tools that are available to compare GIS data to MSAG and TN records? Also, how could we go about getting a copy of TNs and the addresses that go with the TNs?
Okay, great question. Yeah, so I did sort of cover that there at the end, that we do have a product called MSAG, and that is Intrado's product that works with Esri's desktop app, ArcGIS for desktop. That product enables you to do comparisons from your GIS data to your MSAG by building a GIS-based MSAG from the road center lines, and then doing a compare against the tabular MSAG. And so that system is designed, specifically for that purpose. It also does a comparison of your alley records, or your alley addresses, and compares those to the address points in your data, so that you can see which address points you're missing, and that'll give you an idea of which address points you might need to add to represent the alley. As far as obtaining the alley, generally you would contact your 911 services provider and request like an alley data extract, or ADE is usually what it's referred to, but you get that alley data in an extract. You might have to purchase it. It just depends on who the provider is, but you can get that into like an Excel format, or otherwise a format that you can use for those comparisons. Okay, next question.
Okay, great. So we've had a couple questions about the PITA flow relative to call location. So will PITA flow include the coordinates of the call, in other words, cell phone location, and further, would it include the Z or elevation coordinate?
That's a great question, and it's one that's actually asked quite a bit, and it's been the topic of a lot of conversations that I've been involved with, at least at some of the NENA development conferences and other conferences. So currently, the location, or the technology to embed the location within a cell phone call or wireless call, when the call is placed, is not currently available. So when the call is placed right now, just like we're doing with E911, we're going to route the call based on the cell site and sector, and get the call to the PSAP, and then it's basically the phase 2, or basically that rebid, would have to occur to get the XY associated with the device, and can then kind of display the actual location of the caller based on the device or the network XY. In the future, we're hoping to, I think there's some FCC requirements that are coming down the pike eventually, to where the location can be embedded with the call when the call is placed, and then route the call actually on the XY of the caller. But currently, right now, within NG911, we'll still be routing like we are with the site and sector, cell site and sector. Lastly, the last part of that question with the Z value, I have to get back with you on that. I believe that it will be included, but I'm not sure right offhand if the PITA flow has a space for the Z value, but it does have a place for the XY for sure. I just need to double check on the Z value, so that's a good question. We'll follow up with you on that. Maybe time for one more?
Yeah, that works. Is there a particular standard for placing, in other words, where to place an address point or the structure or a parcel?
That's a great question. I didn't mention this and I probably should have added this standard, our NINA document to the presentation, but there is a document out there in the NINA documentation, and it's the site structure address point. I'm not sure if it's a standard or basically just a recommendations document, but basically in that site structure address point, they cover everything as far as where to place the point, whether you're placing it on the structure or on the primary structure, if there's multiple structures within a single address, or if you want to maybe look at placing the point on the driveway access point, if there's, let's say, a house or a building that's really far off from the main road, and you have like a mile-long driveway, so you want to know the actual access point to that location rather than the structure itself. All of that is covered in this site structure address point document, so I would point to that one for the maintenance of the address points and placement of the address points themselves. I think we've got a couple minutes to the top of the hour, maybe one more question if we have time for it.
Yeah, so in that same kind of vein, someone else had asked, how important are structure points in G911?
I would say they're very important. I mean, I know there's been some controversy within the work group as to whether or not address points should be considered required within the G911 data model. And as I mentioned earlier in the presentation, they are not required, but they are strongly recommended. Reason being, it's kind of a funding issue. It's difficult to require or mandate that address points are included because it is more difficult to go collect every single address point out in a region as opposed to just maintaining the street center line. But when we get down to really wanting to reduce response times, find callers as quickly as possible, address points are important, especially when you consider the fact that more than 70% or around 70% of calls are placed from wireless devices. That might seem like the address points are less critical because they're not coming from a house or they're not coming from a business as much, but it's very important because people that are, callers might associate with common places or say, I'm on this bridge or I'm at this golf course on hole number 9, and you can have the address points don't have to be just address points. They can be commonplace or they can be sites like a cemetery or a golf course like that. So if you have, the more points you have in your data, the more detailed the call taker visual is, so that when the wireless call comes in, even though it's not a landline, you have these commonplace points to reference and search. And so I would say they're very important, and much, in a perfect world, it'd be better to have more address points or have all of your address points as opposed to just road center lines.
Okay.
Hey, Raymond, I think we're right at the end of the hour, so I think we probably should take that as the last call. But I want to thank Raymond and Sean for supporting this webinar. And again, for all the people that may have missed it in the beginning of this webinar, we recorded this webinar, and the video will be posted online in a few days. So anybody who signed up for the webinar, you will get a link to that. But again, I want to thank Intrado and Raymond for supporting this event and doing a great job. So thank you very much. And thank you, everybody, for attending.
Thanks, Brett.